Let's talk about rate of work problems today. Now, rate of work, before we even get into that, let's kind of just define rate. Okay, so what is rate? Well, rate is basically a ratio in which two measurements are related. So in other words, how much of a job, rate of work, like how much of a job you can do per hour. Okay, and so what we're going to talk about is, what if we were to take how long it takes one person to do a job, take another person and combine their efforts together. Okay, how long would it take for them to do the job together? So let's take a look at this first example. It says Barry can do a certain job in 6 hours, whereas it takes Sanchez 3 hours to do the same job. How long would it take them to do the job working together? Now, some people might say, well, that would be 9 hours, 6 plus 3. But hopefully that doesn't make sense to you, because if you have two people doing the same job, it should take less than what it takes each one of these people individually. So what we're going to do is this. We're going to talk about these people not in terms of how long it takes them to do the job, but rather what their rate of work is. So we're talking about Barry and Sanchez. So let's talk about Barry. So Barry's rate of work. So in other words, if Barry, it takes him 6 hours to do the job, how long does it take him to do, or how much of the job could he do in 1 hour? Well, if it takes him 6 hours to do the whole thing, he can do 1/6 of the job, okay, in an hour. Now Sanchez rate of work is a little faster. He can do the job in 3 hours. So how much of the job could he do in 1 hour? Well, he could do 1/3 of the job in an hour. Now, in order to determine how long it would take them to do it together, well, together, if you take Barry's 1/6 of the job per hour and add Sanchez's 1/3 of the job per hour, that's going to equal how much of the total job per hour can be done. Okay, so when I go through and solve it, life is actually pretty easy now. I just have two fractions. I'm going to add them. So how do I add these? Well, get some common denominators. So I'm going to take 2 over 2. So it would be 1/6 plus 2/6 equals 1 over t. So that would be 3/6 equals 1 over t. Now, that doesn't quite help me yet. I'm not looking for 1 over 2t. I want to solve t. So you notice what we have here is a proportion. So I'm just going to cross multiply. T times 3, 3t. 6 times 1 is 6. If I move this up since I'm running out of room, 3t equals 6, divide by 3, t is 2. And what does that mean? Well, that means that together they could finish the job in 2 hours. Together they can do the job in 2 hours. Okay, that's exactly it. So again, it's just going through and comparing these jobs in something that's similar. So for instance, by comparing Barry's rate of work, or pardon me, talking about Barry's rate of work in terms of how much he can get done in an hour. How much can Sanchez get done in an hour? Okay, and adding them together will tell you how much of the job you can get done in an hour. Okay, and solving that will actually tell you how much or how long it would take to do the entire job. Okay, let's try again. All right, let's try another one. Okay, so here we're talking about Peter and John. So we'll just shorten it. It says Peter's rate, John's rate. Now Peter can mow the lawn in 40 minutes. So that means he can do 1/40th of the job in a minute. Now John mows the lawn in 60 minutes. So he can do 1/60th of the job in a minute. So how long will it take for them to mow it together? Well, it'd be 1/40th plus 1/60th would equal 1 over t. Common denominators, looks like common denominator might be probably 120. So I'd multiply this by 3 over 3 and this by 2 over 2. Okay, so this would be 3 over 120 plus 2 over 120 equals 1 over t. So 5 over 120 equals 1 over t. Okay, so we have a nice proportion. I'd cross multiply. Okay, and when I do that, I'll move it up here. You get 5t equals 120. Divide by 5. T equals 24. And what does that 24 mean? That 24 is 24 minutes. Okay. It will take them 24 minutes to mow the lawn. Okay, so pretty straightforward there. You can see two different examples, and it's really similar to one another. Okay, simply writing them in terms of how much of the job they can get done in 1 hour. Okay, last one. This one's a little bit different. Okay, this one says you have an oil tanker, can be filled in 8 hours from one pipe. Okay, it can be drained from another pipeline in 10 hours. How long will it take to fill the tank if both pipelines are used? So in other words, if we just draw a little picture here, say we have this tanker, okay, and we got one pipe here that's pouring stuff in, but then over here we have a pipe that's sucking things out. Okay, and so when we talk about the rate of work, we'll just talk about, we'll call this pipe number 1 and this number 2. So pipe 1's rate, it can fill this whole thing. It says it can fill the whole thing in 8 hours. So in other words, in an hour, it can get 1/8 of the job done. But the other one can drain this thing in 10 hours. So pipe 2's rate. So it can get the job done, or it can get 1/10 of the job done in an hour. But this time, they're not working together. They're working against each other. So the difference is you're going to take your rate of work for pumping in, and this time I'm going to subtract what this other pipe takes away. And that should tell me how long it'll take. Okay, so hopefully that makes sense. They're working against each other, so they're going to be subtracting. So common denominator, I believe, is going to be 40. So let's multiply this by 5 over 5 and this by 4 over 4. So this would be 5 40ths minus 4 40ths equals 1 over t. So that's 1 40th equals 1 over t. If I cross multiply, I'd get t equals 40. So how long will it take to fill a tank? It will take 40 hours to fill the tanker, or the tank. Which hopefully makes sense that it takes a long time. You got one pumping in, one pulling out, so they're counteracting each other. But the idea behind all three of these is the same, is put the work in terms of how much you can get the job done in an hour. And when you do that, you can set up these nice, fairly simple little equations here to solve. And that's it. That's how you solve rate of work.